It's older
Yeah,
than I
it's
am.
all. Sorry. That's, for a very long time, I knew. Come on, James, right? Sorry, it's getting. You get younger, yeah. But for very long, one of the first guys I met in the VoIP area, probably one of the first SIP Express router users out there. He will share a bit more eventually during the breakthrough tour. Otherwise, let's see, building 4G mobile networks with open source. Thank you, James.
Thank you, Daniel. Hopefully, I can inspire some of you to work in this exciting new area. Now, as Daniel said, I started off doing voice over IP back in the old days, but since then we've kind of evolved on into new areas. And the area that I've been working in over the last kind of 10 years is in the mobile space. Many of you may know that I spent a number of years, about 10 years, at TruePhone, building an international mobile network operator. But I managed to escape from TruePhone about 2.5, 3 years ago and set up a new outfit based in Northern Ireland called Telet Research. And our mission is to build mobile network cores in order to enable anybody who wants to deploy their own radio network to do so. Hence the loaded question to Thomas earlier. So I'm going to talk about building 4G mobile networks with open source. Yes, you can do it. Big lumps of this are stolen from other people, by the way, I hasten to add. But anyway, so my objective is to make setting up and using a private LTE network as easy as deploying a wireless access point. At the moment, it certainly isn't like that at all. It's a very tricky thing to do. Yeah, well, I'm going to ignore that. Let's talk about the traditional way of building a mobile network, which looks something like this. You go out to a company like Nokia, Ericsson, or Huawei, and you spend a huge amount of money and a large amount of time putting together a conventional mobile network, which looks a bit like, oh, you expect to spend around at least 6 million doing it. And you start off with a room that looks like this in a co-location center, and you put in lots of power and racks of equipment. It takes a long time. It is very complicated. And you end up with something which looks a bit like that, which you really, and a bit like that. But we don't want to do that because we're the open source community. We don't do things that way. So there is an interim way of doing it, a slightly more modern way of doing it, which is to use general purpose computing platforms. So your normal Linux servers use virtualization, and there's lots of spelling mistakes on there because I've stolen this slide. You can buy commercial software now from companies like Zonetics, Attocore, Quartus, which is actually spelt with an O, not an A, to build a mobile network. And you can throw one of these together in of the order of 6 months. And I noticed that there's somebody in the back of the room there, the famous Mr. Magnus Kelly, who is the sort of person who did exactly that, built his own mobile network in UK using this kind of stuff. Still reasonably expensive doing it this way. You would look to an outlay of between 250,000 to 500,000 pounds. Is that about right, Magnus? Yeah, about that. That's still a little bit out of our league as open source guys. We don't normally run around with that kind of money in our pockets. So we've got to do something a little bit better. Oh, that's the sort of radios we use. And this is what that sort of configuration might look like when it's deployed. Now, open source. To look at the problem now, we we need to work out what we need to do with open source. And if you open all the mobile standard bits and pieces, you end up going to 3GPP, and you see lots of scary diagrams like this. And these, quite honestly, are designed to scare the hell out of you and to give the impression that building mobile networks is really, really, really difficult. Well, they're not really, because IMS is nothing more than SIP, and because we're Kamailio people, we know lots about SIP, don't we? And plus diameter. And hey, yeah, I'm not going to say it. I'm not going to steal Carsten's line about it being twice as good as radius. Yeah, it's awful. I've said it now. But it's only SIP and diameter, and hey, Kamailio now does diameter as well. So if we take that really scary diagram and we redraw it in a Kamailio world, it kind of looks a bit like that. And if you're really risky, you put a bit of SEMS. It doesn't have to be SEMS, it can be free switch, or even asterisk people. So in there. That diagram looks a lot friendlier, doesn't it? We think we can do that. So, but I'll come back to the guts, the EPC, a little bit later. Thomas, a little bit earlier, talked about things that stop us. And one of the things that traditionally has stopped us is availability of spectrum. Unless you've got spectrum you can use, mobile spectrum, then you can't really do anything. And historically, all of the mobile network usable, the good spectrum, has been allocated to mobile network operators. Is that what it says there? No, it isn't. I'm making this up as I go along. But however, things are changing. All of a sudden, we're seeing things like shared spectrum schemes coming in. So examples of these in the US, US now have something called Citizens Broadband Radio Service, CBRS. 3.4, 3.5 gigahertz, anybody can get access to spectrum. In Germany, Thomas mentioned it, with the 3.4, 3.5 megahertz bands, a certain percentage of it will be available to anybody that wants it. Even better, in UK, we are getting not one band, but 3 shared access bands. We're getting 1.8 gig, what used to be called DECGAR band for narrowband use. We're getting the top 10 megahertz of band 40, that's 2390 to 2400 megahertz, which is great for standard LTE use. And then big chunks of spectrum, 3.8 to 4.2 gigahertz for 5G use, 20 megahertz channels. So a huge amount of spectrum becoming available, which is hugely exciting. And the way that it works in the States, and likely to work everywhere else, is you can actually bid, or you will be bidding for spectrum. It'll work a bit like DHCP, where you bid for a spectrum, you get a lease for a lump of spectrum for a certain amount of time. And the mechanisms for doing that are all kind of worked out. There's a lot of spectrum becoming available. This is a quick summary of some of the stuff that's floating around. And I'll make this available afterwards. So a lot of spectrum becoming available. It's now not a problem to get spectrum. So if you've got spectrum, what's the next big problem? Well, the next big problem is how you authenticate, how you join the network. For that, you need something like a SIM card or SIM cards. So you've seen these. quick word about SIMs. SIMs actually are not the little plastic things. The SIM is the stuff that's actually in the plastic thing. They come in various flavors. For 2G, you have a SIM. For 3G, there's a USIM. For 4G and IMS, you have an iSIM. And they can all live together in one of these, or they can live in an eSIM. Yeah, lots of different ways of doing it. But if you're an open source guy, getting your hands on these, it can be a little bit problematic. It's not easy to go off to somebody like Gemalto and say, can I have half a dozen SIM cards, please? Because they don't do it. So you have to find a way of getting your hands on some of these. Let's talk about multi-IMSI SIMs. Normally a SIM has one identity. It's a thing called the International Mobile Subscriber Identity, or IMSI. But over the last few years, multi-IMSI SIMs have become popular. So what a multi-IMSI SIM is, not surprising, it's a SIM with more than one IMSI. The TruePhone SIMs that we built a couple of years ago are a good example of those. Yeah, at any one time, only one IMSI is active. This is how you attach to the network. Note the IMSI is not your telephone number. It's just a means of attaching to the network. And what we did with TruePhone was that once you're attached to the network, then all of your telephone numbers and profiles then are mapped onto the active IMSI. So this can be likened to James Bond with his Aston Martin DB4 with the rotating number plate. So the idea there is that you drive around internationally, you go between different networks, and you use different IMSIs to attach to different networks. So you can change your identity as you go. Not surprisingly, my team also do SIMs. This is our first generation one. The term MONE stands for multi-operator neutral host. The difference between our SIMs and the TruePhone SIMs is that ours are not only multi-IMSI, but also multi-crypto. You say, why? Why do you need multi-crypto? Well, the answer is if you're going to be running your own infrastructure, you probably want to run your own crypto as well, so that you can authenticate your own SIM cards on your own platform. Hence, multi-crypto. Integrated in there will be things like OTA, over-the-air rekeying of the SIM, so you can push new IMSIs over the air and also generate new cryptographic key variables. Now, let's talk about the exciting things that we've been getting up to in the Chalk Valley. In order to prove that we can do this, we've actually set up a pilot project, which we've got government support for, in a place called the Chalk Valley. By the way, Chalk Mobile, the reason it's 4 is because it's 4G. I don't know, we thought it was pretty good. This is where I live. It's in a valley in the southwest of England called the Chalk Valley. It's also in an area of outstanding natural beauty. And as you can guess, if you live in a place like that, it's rather difficult to put up 30-meter high masts. The locals don't like it. They try and cut them down. This is going to go. It's got, oh, no, go back. Yeah, there. So this is the area. Salisbury up at the top right-hand corner. Everybody knows where Salisbury is now. Yeah, in fact, it's the only place in UK where the hospital is equipped to treat nerve agent, and was before the FSB decided to take out a Russian with nerve agent there. That was a very silly thing to do because they obviously survived. And the FSB general responsible for that had a heart attack later, so he's not around. But anyway, this is the area. Which is the largest mobile hotspot in the south of England. So our testbed, we actually deployed 5 LTE cells around the village of Bowerchalk, which, and actually I live just there. not surprisingly. Just to prove that we could do it. So this is what the kit looks like. Backhaul, we're using dark fiber, courtesy of British Telecom. So we pick up a fiber from a telegraph pole and we run it out to a fiber router. These are the cells that we're using. These are Acceleran E1000s operating in band 40, that's 2.3 gigahertz, 2x2 MIMO. Up the top there, there's a box which is actually a MikroTik box, which is a point-to-multipoint, which then supplies the subcells. And this is an example of the subcell. This one's actually on a cow barn in Chalk. This one's on the village hall. Note the little dish, which then links back to the MikroTik. We're getting about 300 megabit per second across that link for the backhaul. Here's another example. This is actually my chimney, slightly different configuration. All of the cells that we put out in the Chalk Valley have got different antennas because we wanted to trial different antennas. So this one's got two reasonably low gain antennas. There's the MikroTik again. The mushroom up at the top is for GPS for timing because we're using TDD LTE. So timing is really important. And just to prove it works, this is at a range of about 5 miles. Not particularly strong signal, but because it's a Chalk Valley, it's very electronically quiet. So it all just kind of works. This is a very oversimplified version of how it all works. So we've got multiple cells all running back to a central router, which is actually located at the local telephone exchange, which then runs back into our core. The core, in our case, is in a large colo in London, where we run our SMSC. We've got a diameter routing agent here, which works out whether it's one of our SIM cards or whether it's a roaming SIM card, so anybody from Vodafone, O2, EE, or 3. If it's one of ours, we authenticate locally on our HSS. If it's somebody else's, we fling that off up through an international carrier partner and back into the other operators so that they can authenticate. And if we can authenticate them, they can join the network and roam onto our network. We've coined a new term for this. We call this reverse MVNO. So in an MVNO, you have your SIM cards, which then roam onto the operator's network. In this scenario, we have the operator's SIM cards that roam onto our network. So reverse MVNO. That's hugely oversimplified, but you kind of get the flavor. So yeah, defining the terms. Multi-operator neutral host is this. I'm not going to read that because you can. But that's what our aim is, to offer a multi-operator neutral host service. So enough of that. Reverse MVNO, I mentioned it, that is this, and that's kind of what we're doing. One thing that is hugely complicated that would stop you from doing this is this business of how you settle for the traffic. Now, the traditional way of doing this is using a GSMA TADIG code, tap record-based settlement system. The problem with that is that you have to account for every last little bit of traffic. It's hugely overcomplicated. In fact, it's a load of rubbish. It just doesn't work if you're really teeny tiny. So we've come up with a different way of doing it, which is based upon something that we experienced in America. One of the things we did in TruePhone is we bought a small rural operator in Montana. Huge amounts of fun I had, racing around Montana doing things with... it It was wonderful. But one thing we learned is that in the US, if you're a tiny little operator, you don't do that TADIG settlement stuff because it's just far too difficult. They do something called mutual forgiveness, which works a bit like this. So instead of accounting for every last little bit of traffic, or instead, you just keep running totals of the traffic in real time between the different networks. And it's like a seesaw. And whilst your traffic remains roughly in balance, nobody pays anything to anyone else, which is great because it's really simple. And of course, if you don't generate invoices, there's no tax. We like that. It's brilliant. However, you've got to be prepared so that if your traffic does go out of balance, you've got a mechanism of dealing with it. And the way we do that is we define agreed thresholds with each MNO, at which point, if you go that far out of balance, it triggers a recentering payment. It's a bit like a buffer recenter in telecoms. So it recenters you back to zero. And that uses funds that are kept in escrow. So it's an immediate payment. It's not something that takes weeks to settle. It's done immediately. And once you're recentered, off you go again, mutual forgiveness. So by doing this, we reckon we can reduce the cost of operating your small MNO by about 30%, because billing is probably one of the most expensive components of the whole thing. So you just do away with it. Yeah, I wouldn't call it mutual forgiveness. We need to think of a proper name for it. But this is the way we're doing it in the way we're doing it. Okay, let's talk about building your own EPC now. In our Chalk Mobile setup, we actually ran an EPC on each of the E1000 radios. You can do that because they have an 8-core Cavium processor, or Linux-based, quite a lot of grunt. You can do that quite easily. But you know what? Whilst it worked, it's not super duper. It's not the best way of doing it because you end up with multiple EPCs that you have to manage. The radios, because they've got these big Cavium processors in, are reasonably expensive. They're about £2,500 a pop. And we really need to get that price down if we're going to roll out to the open source community. You don't want to be paying £2,500. You want to be paying £250. So the way we do that is we bring all of the EPCs together in one place. And I've got 5 minutes. I'm going to have to go quicker. So lots of people building EPCs using Raspberry Pis. In fact, here's a Raspberry Pi here. Bit of a corporate plug. It's a corporate gizzard from Voxpo. But the problem with Raspberry Pis is they're not super duper at networking. You can do better. And in fact, here's something that does networking a lot better than a Raspberry Pi. Anybody know what this is? Yeah, it's a good old RB2011. Absolute brilliant bit of kit. They're everywhere. In fact, it's great to see the Pascom guys have got one in there doing all the video streaming. Wonderfully cost-effective. It's about 100 quid, about that for one of these. They come in different versions. Hugely powerful. And you know what? You can run VMs on it, can't you? So, on this rather battered-looking RB2011, which I bought off eBay for 25 quid, I'm running Kamailio and FreeSwitch. Can you believe it? And the great thing about these is they come with some really good hardware support, gig Ethernet, and hardware support for crypto, so the hardware acceleration. Absolutely wonderful. And these are the big ones. They come in smaller versions. This is a slightly more modern version that we're using for our little islands of connectivity. The way we're doing this conceptually now, we can put an EPC on here with its own VPN link, SCTP. I didn't mention SCTP. In the IMS world, rather than using TCP and UDP like the rest of the world, IMS tends to use SCTP, little complication there. Anyway, we equip somebody with one of these, pre-configured to connect back into our mobile core, running an EPC. Then all you have to do is to plug in an LTE or even later 5G radio, and you end up with a reverse MVNO, multi-operator neutral host system that just kind of works. So, oh, and by the way, these things come in smaller versions as well. I love MikroTik. Look, that's a MikroTik router too. Can you believe it? And in the hands of, where's Sandro? In the hands of Sandro, you can do lots of naughty things with these. They're absolutely brilliant. But anyway, I think I'm probably out of time now. I've probably got, I got some more slides. We'll stop there. So let's do some questions because I know that there are some people who are looking to build 4G, 5G networks. Anybody got any questions?
Okay. Oh, too many hands in the first row.
Usual suspects.
Okay, we start from...
We have to go quickly.
There are people not too far away, James, who have said there are those who talk about it and there are those who demo it.
Yes.
You are?
Yeah, well, we built it. We're doing it. Phase 1 is complete. And in the
No, I meant
Valley,
today. I meant dangerous demos.
Yeah. Where we're now moving to phase 2 of Chalk Mobile, which brings in the MNOs. In order to get government funding for the next phase, we're looking for about a tiny amount of money, just 1.5 million, to deploy between 50 and 70 cells. The government have turned around and said, yeah, we'll throw you the money, but you've got to have the MNOs on board. And so for the last 4 months, we've been mounting a charm offensive with the MNOs to get their support. And the latest news is we've now got spectrum from one of the UK MNOs, and we're deploying in band 3, and that's not decked guard band. This is a big chunk of FDD spectrum in band 3, high power, and in band 38, that's 2.6 gig TDD. Again, relatively high power, much higher power than we did in phase 1.
So is that a yes to dangerous demos?
I think so, yeah. Any other questions? Quickly, go on. Steve.
Firstly, I can attest that I put one of your cells, your eNode Bs, in a gym bag with a MikroTik, drove it to the middle of the countryside down in Southampton, plugged in, and just worked.
Yeah, Steve is an example. He's been running one for a number of months.
I have a question about the billing. You've got a core network, and you've got the mutual forgiveness and all the bits and pieces above.
Yeah.
Right? I think one of the key points for your network is the IMSIs that you can sell to other people. Now, if you sell IMSIs to other people that will then have IMSIs that will be able to roam on UK networks and other networks, but using authentication of your switch, and they have to bill their customers, how is that going to work?
Yeah. Okay, one of the very clever things we've done here is we have said we're not going to issue our own SIM cards for anybody that we want to bill. The reason for that is if you do that, then you've got to build a billing and rating engine. So a much better idea is just to allow other networks to roam in, and the other networks clearly have got their own billing system. By doing that, we generate roaming credits, which we can then use with our SIM cards on other people's networks. That's what you're saying. And there's a secondary...
It's sort of, but if I take SIM cards from you to build an application, because I've got a niche application for a niche set of customers, and I've got my infrastructure, and then I connect to you to issue your IMSIs to my customers,
yes.
I need to bill my customers. So my customers are going to be making calls probably and most likely across all the other UK networks. And it's how do I get my billing information? Am I going to have to manage that myself, or what are you going to give? I know it's an unfair question because
It is an unfair question. That's a very nasty question.
Yeah, I know. Of course, it's a
And
nasty
I'm not
question.
gonna-
This is the beginning of dangerous demos. This is a dangerous question.
Yeah, thank you for that. And in true form, I'm not going to answer that one. There's
Last question then.
there's
Who
Michael
want-
right at the back.
Okay. Henning,
Oh.
can you get the microphone to Mike there?
Come on,
The
Michael.
last guy there. He's
Oh.
allowed only with half a question today.
So isn't that from a billing perspective, isn't that a little bit dangerous because you can end up on the wrong end of an arbitrage deal, especially when you're talking about sometimes waiting to find out for months?
No, because all we're doing is giving the MNO access. They're actually dealing with the termination of the. Are we talking about voice calls here? It is
No,
complicated.
just data because you can have credits.
Yeah,
That,
I
that-
haven't
that
talked.
you've already been given, and then all of a sudden you have a customer.
Yeah, I haven't
that
talked
uses
about the
a massive
full
amount of bandwidth.
full business model here. The business model for Chalk Mobile is all about offering MNOs their own network slice. So 3GPP released 15 slices where they then control their own slice and they determine whether you do local breakout or back all the data back into their core network.
The talk was
I'm not
about
answering the
building
question,
the
am I?
network with
Unfortunately.
open source. And I see people on the business and want to do money here, but yeah.
But anyway, you see what the objective is. The objective is to build something with open source, which then works with the MNOs. And
it works.
And yeah, it kind of works okay. We've got to go further. We've got to do more work with the MikroTik stuff. So I'm looking to find lots of enthusiastic people to build lots of EPC bits on MikroTik.
Okay.
You can have a lot of fun with that.
Okay, thank you, James. Not
Thank
to
you.
postpone it.